Another way to demonstrate change in state is to take an electric kettle and boil some water. Now, what we see coming out of here that we commonly call steam is really condensed water vapor. The water vapor that's coming directly from the water itself is invisible. And so we see the water vapor condensing and forming then kind of a cloud as it comes out of the kettle. If I now place a beaker of ice water over the steam that's coming out, you can see we're getting condensation and dripping of water off the beaker. It's important for students to realize that a change in state requires energy. And so when I convert water into steam, I have to add energy, in this case in the form of heat energy from electricity. That heat energy is required for the molecules to be separated from the liquids into the vapor. So they require energy in order to go into the vapor state. And when I cool it, I'm taking energy away from the vapor and allowing the molecules to come together again in the liquid state. And if I collect the water in a beaker, we then would have distilled water. And you can ask students to taste the distilled water, and it tastes pretty much the same as ordinary water, except of course it no longer has any minerals in it. Another way to show that a change in state requires energy is to take, say, a dropper and go around to the students and place a drop of water on their skin and ask them how it now feels. And if they move the hand around a little bit, you can actually feel it getting colder. So why does the water make it feel colder? Well, that's because the evaporation of water actually results in heat being required. And where does the heat come from? Well, it comes from your skin and causes then a cooling effect on your skin. Now, we can demonstrate that as well by taking a thermometer, and I've added a piece of gauze to the tip of the thermometer. So this is just some gauze from the first aid kit, and I've taped that on so it forms a sleeve over the bulb of the thermometer. I can then wet the bulb and cause evaporation. So the temperature of my thermometer currently is 23 degrees Celsius. I'll put it into the water and soak it. So now we have what we call a wet bulb thermometer. And now I'm going to move it around in the presence of the air and cause evaporation of water from the thermometer bulb. You just want to make sure that you don't hit anything, because the thermometer, of course, is easily broken. And as I move it around, I'm getting a cooling effect as the water evaporates from the bulb. And I'm down to 16 degrees with the little bit of shaking that I've done so far. You could also take a hair blower and just blow air on it. Have a second thermometer that's dry and hold them side by side, blow air on the two of them. The one stays the same temperature, the other then cools down. Of course, make sure your blower is not on a heat setting when you're doing that. This has important implications for climate, for relative humidity, for cooling our bodies. Of course, when you're really hot, one way in which your body cools itself down is through evaporative cooling. You sweat, the sweat evaporates and absorbs heat from your body and cools you down. The temperature now is 14 degrees.